In this project, an attempt has been made to investigate the effect of the movement of a jet ski on the border of two fluids, water and air interface. The computational domain consists of an inlet wherein the water enters and a pressure outlet. The multi-phase VOF model is activated for solving multi-phase flow equations, and the standard K epsilon model is exploited to account for the turbulence in fluid flows. The geometry of this project is designed in ANSYS Design Modeler. ANSYS Meshing software also has been used to create a computational grid and mesh for the geometry. Also, due to the sensitivity of changes in important components of the flow, such as velocity and pressure near the boundary of the two fluids, and also where the two phases collide with the body of the jet ski, we have tried to use finer and better grids and meshes. The mesh type used in this geometry is unstructured. There are some key assumptions considered in this project. The simulation is done using pressure-based solver. The present simulation and its results are considered to be steady and do not change as a function of time. Also, the effect of gravity has been taken into account and is equal to minus 9.81 in Z direction. From the scale mesh section, we can check the dimensions in all three directions and also view the length unit that is in meter. Also, from the mesh display section, we can display every faces and surfaces related to the boundary conditions, including walls, inlets, outlets, symmetries, and so on. The volume of fluid or VOF model is used for multi-phase flow in which the boundary or contact are between two different phases is clearly defined. In fact, in this multi-phase model, the different phases do not mix. Free surface, laminar flows, jet phenomena, and movement of large bubbles into the liquid, pool boiling, fluid fall like a waterfall, spillways, and so on are some examples of using the VOF model.
You can buy this learning product to obtain a geometry file, mesh file, and a comprehensive training video on how to set up, meaning the pre-processing, solution, processing, and extracting results, which is the post-processing and analysis.
And also the turbulent kinetic energy. The drag force occurs in the y direction in this CFD simulation based on the direction of the jet ski. Here we can see the drag force and also drag coefficient. And if we change the direction vector to z direction, we can obtain the lift force and also the lift coefficient.
You can buy this learning product to obtain a geometry file, mesh file, and a comprehensive training video on how to set up, meaning the pre-processing, solution, processing, and extracting results, which is the post-processing and analysis. To benefit from Mr. CFD services, including simulation, consultation, and training, contact our experts via info@mrcfd.com.